What I also would like to mention here is that perhaps when you write your code and you have your lengthy if-else letters like this, which most likely are going to look like this, arguably this is more readable, format. This condition is always evaluated. This condition is evaluated only if the previous condition was false, and so forth. So the likelihood of executing this condition and evaluating it is much less than, of course, this and this at the top. So perhaps the most expected conditions should be put at the top of this if-else letter to, could kind of optimize your code and just say that, well, you know what, this is something I always want to analyze. And look, this subtotal condition I want to analyze only if it doesn't equal that, it doesn't equal something else, and so forth and so forth. So it's really kind of hidden under other conditions. So I guess if you just know how it works, and why would anyone ever construct if with else if in a row, then you should remember this is just a set of mutually exclusive choices, right? And it's called if-else letter, or if-else statement, and it's just the way it works. So also, of course, else at the end is optional, right? So this doesn't have to be in place. It's just optional as any other else is optional. By the way, another take on this could be, maybe, to say, so let me kind of sacrifice my efforts and do source format again. So now I formatted everything the way NetBeans prefers to format everything, and it collapsed into this view now. But it would be also possible to do this, right? To just say, oh, forget about else. Why bother with else? Just do something like this. So logic, although this is a legitimate program and it does analyze all these conditions, but it does something completely different. Because or it potentially does something completely different, because in this case, without the chaining of if else, if again, without the chaining of if else like this, this condition is now always analyzed. This condition is also now always analyzed. So this is no longer a set of mutually exclusive choices. It's possible that this will execute and this will also execute, and something else will also execute, whereas before there was a guarantee that only one of these statements will execute. So the logic is different. The logic is here different. Okay, so it depends what you're trying to program, what you're trying to express, what you're trying to analyze, what kind of conditions you're dealing with. So be aware that both are the possibilities, but this is generally viewed as a set of mutually exclusive choices. Let's move on. Introduction to loops. Very good. So if when we look at our if statements, in general, we expect the path of execution to take place as follows. Well, we always know where a program begins. It begins by looking for main method. So now that the main method is found, so this statement is executed first, next, next, right? If the condition is true, then we're going to run this, and so forth, right? So it's sort of like a fall-through model that we begin at the top. We know exactly where the execution enters our program, and we follow the logic simply looking, top-down approach. Okay. So then if else also create the possibility of branching, right? Because we say these are two alternative branches of the code. They will never execute sequentially one after another or in parallel. They're mutually exclusive. So they logically represent two separate branches of execution. If condition is true, then this branch of execution takes place right here. Otherwise, this branch of execution takes place. Okay, so two mutually exclusive branches of execution. Yet again, you may want to, and also, let's take another example. Take a look at this if statement. If this condition is false, as it is, because I said customer type is Z, okay? So it's not T. Compare customer type equals T is false. So I am predicting that this will not run. This will be a branch of execution which will simply not take place at runtime because of what I can predict looking at the values. But at the same time, I expect that this piece highlighted right now will be skipped. But at the same time, anything that comes after this if statement will execute, right? So you know, the condition is evaluated. This statement is never executed, but the execution will continue. And so it will continue, you know, here and here and here, whatever. I'm not looking at any details, just basically looking down the code. So, again, there's some predictability to this logic. But at the same time, sometimes I want to do things multiple times. And I want to do things in a loop. For example, I would like to say, let me do it right here. I would like to maybe ask user, so scanner, scanner SC. I know, you know, I always use the same names, just like main is always the same name for your main method. SC for me most of the time is the name of my scanner device. So say scanner equals new scanner, right? And it wants to take system dot out dot in. I'm sorry, dot in as a stream device from which to parse the input, right? And then I will use my secret trick to say fix imports, because I'm too lazy to type the import for scanner, but I'll say OK, and what it did was inserted this import statement for me, so it kind of kindly allowed me to you know, modify my code for me, expecting that the scanner is a well-known object. So then right here I may say system dot out dot print line, or just print enter customer customer type, I guess, right? Enter customer type. And then I can say customer type, string customer type, just take the variable, I guess, and say scanner next, right? Just to get whatever they type, next word that they type. So, okay, next. Just get the next token from the input. Fine. But then I want to say if, perhaps, if the customer type, equals still equals Z, right? If they type uppercase Z. Oh, my mistake. Of course, I need to say equals, and then type, you know, string Z to do the value comparison here. See how easy it is to, because you kind of mechanically type, it's easy to remember a double equal sign. So this would be the appropriate comparison of customer type to whatever they type. I may say print, right? Print bad, something like that. Bad customer type. please retry, right? Please retry, exclamation point, and maybe even print like a new line at the end, and go right back to the prompt. So I need to jump. I really don't want them to let them type Z as a customer type. That's my current intent. So then here is the possibility is to create a loop. And in that loop say while like true forever, while the condition is true, forever do this. And what's going to happen here in this particular situation, this construct, the while loop, will take you will at the remember, like at the end of if statement we were expecting to move on. At the end of while statement, if we reach this brace somehow, if we did get to this is the brace that closes the while loop, you're automatically taken back to where you started with the while loop. So instead of moving from the while loop down here, if you happen to be ending up hitting this closing brace, instead of falling through the program, you're taking immediately right to where the while begins. Now the while takes, while is very similar to if, but it takes the condition, right? So in my first introduction to this while loop, I'm using the condition which is true, which is always true, and therefore this is an endless loop. So I'm never getting out of this endless loop. For me to basically say, well, I'm kind of I'm done with this, and I'm now in good shape, I can say else trying to type, right? I can take myself out of this loop by using the break statement. Maybe, just maybe, it's too complicated, the whole thing. Let's try this again. Control C and Control V. Let's do another version of this loop, which may be even more intuitive to somebody else. So let's